Hey, it's Rob again with Sine Wave Specialties. This time, we're not going to go over concepts, we are going to fix shit. This is the manifold of a pressure washer pump. I think it's either 3600 or 4100 psi. But the pump model is EW4040. This pump has failed. Apparently, water goes in, water comes out, but it comes out the same pressure on both ends. Now remind you, pressure is resistance to flow. So we're thinking almost no pressure, we can assume. Because it's going in the same way it's coming out. Net force is all the way around the same. So that leads us to a couple things. Instead of just ripping this thing all the way apart and trying to figure out what's wrong with it by looking at broken pieces, we're going to do this the right way. The engineering way. We're going to assess this thing. We know what it is, we know what it's supposed to do, we know what kind of fluid it's operating off of, and we know what it's doing on the outside end. So something is wrong. You're supposed to get a whole lot of water pressure out one side, and that's what just garden hose flow. So how do we start looking at this? Okay, so we know this is the inlet, this is the outlet. Pressurizing happens here. This is where the piston pushes in, jams into that water. So we come in here, comes back here, comes all the way up and through these jackets, right here, here, and here. Goes in here, piston comes in, hits this thing, pushes the water up, and then that comes out through this end. How it's regulated is right here. What that is a needle. It's a needle valve. It's like a gate but round. And what that does is it slows the output flow. It creates a higher resistance. This will never see anything more than the resistance it's rated for, but it will reduce the flow on the output end. So if water's just passing through, no pressure, first thing you think of is, well, maybe the piston's leaking. Well, there are little nylon seals in here. Those nylon seals are not bad. I already took them out, I already checked them, I already put them back in. I assume they weren't bad right off the rip. Why? Because, first of all, cam is for pushing. The crankshaft for reciprocating motion of those pistons, those ceramic pistons, on this side had no water in there. Didn't have any oil in there either, but you know, it's not my pump. And on this end, when I took all these plugs out, there was no oil in there. So, I know that these seals are good. I know nothing's broke in the crank side because of the simple fact that there was no scoring on the ceramic discs. If there's scoring, galling, cracking, anything like that, I'd be a little more concerned. Bolts were all good torque. Ceramic coating was good. There was a little oil on it, but not enough to sit there and say the case was full. But yeah, so we get to figure out why this bad mamma jamma. No worky worky. One of the things I noticed on this thing is, oh my god, the Italians just love their blue thread lock. Why not just seal it? I mean, it's brass. It's gonna seal on its own. Yeah, they just loaded this thing up with all kinds of thread lock. I thought there was 2 O-rings at the top. I really did. Because I mean, they got this huge mess. Whoa, where are we going here? Huge mess. And that's only one of the holes. Hey, you know, to each their own. If they want to think it's free, then go for it. So what we're going to do is we're going to go over the concept of how we diagnose this thing without taking it apart. So, like we said, water comes in, goes through here, goes up into the piston. Piston pushes it down, comes over. Piston pushes it in through here. This whole thing gets flooded. Let's just start from the beginning. This whole thing is going to have water in it, no matter where it's at. The only thing that stops the water from coming back this way once it's pressurized is because there's valves. There's valves in these 3 holes, there's valves in these 3 holes, and these are sealed by the pistons. So how does it work? Okay, so water can go wherever it wants, it's flowing, the whole thing has an equal pressured manifold. This is the manifold. But when that pump decides to swing in really hard. Instead of pushing water through this whole jacket that it has access to, it's got check valves. This valve sits in here. This valve sits in here. Alright, this is a feed. This is an output. This is to retain high pressure. This is to make sure it doesn't fly back into the garden hose. So when this guy is in there, this will stop the garden hose from seeing that pressure. This guy will stop the head pressure from coming back in. Let's say you're using this, the guy that I know that owns this thing is using this as a supply line for pressure, or a water supply line at a high elevation. It's like 370 feet or something like that. So what we have to do is, so far I've already put in the order, so I'm going to do multiple videos and shit. I know that everybody likes teardowns that nobody's ever done yet, but well, I already halfwayed it in. So we got new valve kits, we got new O-rings, and these right here. We're going to clean them off. I'm going to show you how to put these back in without messing up the O-rings. Too many people put things back together and it's always dry. I'll show you why that's a problem. That's a no-no. First off, we're going to get these things somewhat bearable to look at. Alright, now that everything's all nice and cleaned up and you got to see that in nice fast forward motion, here's what's going to happen. Alright, first of all, we're going to get these top valves in. These valves are what checks the high pressure system above. How do we know that? Because look, it only goes one way. See it moving? That valve pushes in. So water can go up and through, but it cannot go back down. So first off, trick of the trade here. A little bit of oil over here on the side. What I'm going to do, I'm going to take this O-ring. I'm going to dip it in that oil. Is that going to cause a problem for the pump? No, it's not. As a matter of fact, this is going to alleviate a problem that will happen to the pump if nobody did this. Is there other ways to do it? Yeah, there is. Is everybody going to freak out if I do it the other way? No. Is it going to hurt the pump to do this? No, because the water is going to push through. And all it's going to do is going to blow it right out the other side of the pump. So you don't need to sit there and do this some special way. Just make sure you're not putting it in there when you go to twist the cap back on and it twists sideways on you. Because that would just make you look like a freaking idiot. I'm going to dip the valve too. Then I'm going to slowly but surely push that in. That's one. Alright, so top valves, they're in. We're going to take, just for good measure, take a little bit of oil. We're going to put it in there. Why do we do this? Dry starts are a bitch. That's why. And yes, once again, I know it's a water pump. Shut up. Another thing you'll notice, I'm putting this in partially, but not all the way. You're probably asking me, why? I will show you why in a second here. If you look nice and close, you'll notice that oil, holy shit, frame. Good God, there. You'll notice oil has started to come out. It's because it's incompressible. So what you have to do is you have to run these down nice and slow. So now that we know and we don't have any leaks on the bottom end, that's the cool part, is we can take this thing off and we can do two things with it at the same time. We can let it drain and we'll be able to sit there and do the top part. So yeah, if you're putting stuff like this together and there's a lot of oil in there, do not take an impact and just start slamming it into the manifold. You will crack something. I've actually seen this happen a lot, believe it or not, and you know what it mostly is? Kids, new intakes on their carbureted cars. They'll take something, spray it into the holes on the intake, and they'll run those bolts in all the way up and down the valley, and they'll get hairline fractures. They'll see a little puff of smoke or spritz or something. They don't know what it was. Well, you just broke your manifold. That's what you did. Sorry, union brake. It's required around here. Alright, so we're going to do the same thing with these three right here. I'm going to take these valves and these O-rings and we're going to dip them all over again. So here we go. Alright, that's pretty much it. The EW4040 pump. What was the point of this video? Lots of fast forwards and no explanation of what's going on. But the point of it is, all you need to remember is that there are check valves in this thing. And the key idea is how to assemble something with O-rings without destroying this thing. Now, let's say you don't lubricate these O-rings. Just one of them fails. Immediately, you're gonna get bad line output. This end right here is not gonna do 3100 or 3600 PSI or whatever it's rated for. And then you're gonna go over here and go, oh my God, maybe if I turn it up, you know, it's like your stereo or, you know, a car amplifier, maybe even a dirt bike. Maybe if I just give it more gas, something will go good, the tick will go away. No, it won't. It's just gonna get worse. So make sure anything with an O-ring, oil filters, gaskets, anytime you're putting precision ground machine components together, assembly lube. This does not need assembly lube, so I use oil because it makes it easier. I don't want to put it together dry. And that is how you put together one of these pumps when it's got a bunch of valves in it. So now we understand and review. Water comes in, goes around the back, comes in through these 3 ports, or goes up into the piston cylinder, shoots down to these 3 ports, and then these 3 ports feed up and shoot across here. Alright? Sorry, I misspoke. Water comes in, goes around back, comes in these 3, gets checked. It's one way. It came in, it can't go back out the other way it came. Goes up into the piston. Piston comes in, pushes it, compacts it, shoots it up to here because it can't go this way anymore. Now it's up in here. This checks it, so whatever goes out can't go back in. So that's all it is. 3 check valves, 3 check valves. Shoots it out. And that is it. That's it for today. Easy, quick, simple video. This is Sine Wave Specialties. This is Rob with the EW4040 Italian design pump manifold. Completely brass, 3 piston, 3600 and or 4100, whatever it is. Water, pressure, power washer. That's it. Have a good one.